Okay. You have to compare this with SN2. Just say SN1. SN2 छोड़ दीजिए SN1. Compare the rates for SN1 here. Okay. Which of the following will be faster for SN1? Here you have to compare for so SN1. Write these 4 questions. Let me know.
So I wrote the question.
Then compare it. Anna, which will be faster. Assalamu alaikum, Rifat. How are you?
Walaikum salam.
Were you present in the last lecture, Rifat?
No, I missed the last two.
So did you watch the recording?
I didn't finish.
Sorry.
I started watching it. I have to complete the second one.
So how will you understand today then? The backlog हमेशा रह जाएगा ना. Like whenever you miss some class, at least watch the recording.
Yes.
क्या कीजिएगा बताइए, आज नहीं समझ में आएगा तो? Should I explain once again everything that I have taught you in the last class? रिफत बताइए. I think you were not present in the last 2 class, na? हाँ, रिफत.
Yes.
Done everyone? Jasola, tell me. Zad सारा हुआ आपका?
Yes.
So tell me for the first one, कौन सा fast होगा, A या B?
So B.
B will be faster. Why?
So
Hey,
it
मतलब
not be
हाँ.
any resonance. So
Sorry, what?
take easily and
नहीं. What did you say? Wait. What did you-
resonance. No. For resonance, no. The bond will break easily because it is 1 degree.
अरे Zad, आप
Sorry.
कुछ जो बोलिए वो तो सही से बताइए ना. ये 1 डिग्री तो नहीं है. Why did you say it is? चलिए यहाँ पे 1 और 2 हम कर देते हैं. 1 है और ये 2 है. Which will be faster here? You said 2 will be faster. Why is 2
2.
faster? Why 2?
In second one, the bond will break easily.
Why? Why not in the first one?
First one is having double bond.
तो ये बॉन्ड ब्रेक करना है क्या हमको? लास्ट क्लास भी हमने बताया था. you're giving me right answer but your reasons are not correct. से तो फिर चलेगा नहीं. सेकंड में बताइए कौन सा होगा, SN 1 या 2?
So second one.
सेकंड वन. Why?
Iodine iodo group is easily iodo group is easy remove easy leaving group.
गुड
Yes.
लीविंग ग्रुप.
Good leaving.
सी में कौन सा होगा?
So again B, option number 2.
Why?
So same reason,
आयोडीन तो सी के फर्स्ट में भी है, दोनों में तो आयोडीन है.
but there is CH3 also.
So same reason आप बोल रहे हैं, यानी you are saying that iodine is a good leaving group. Then I am saying that both are having iodine. So जो भी फर्क होने वाला CH3 की वजह से होगा. वही हम पूछ रहे हैं.
CH3.
What is the reason? Okay, what is your answer?
Option
Which
number
is
2.
option number 2 will be faster. I am asking why. Why is 2 faster?
2.
Why is 2 faster or why is 1 slower? कोई भी आंसर एक दे दीजिए. Both are fine.
So one is slower because CH3 group is there. So
So
I think it won't affect. So I'm little confused in C1. I think the option number B is correct first.
अच्छा, डी में बताइए कौन सा होगा, 1 और 2?
Sir, 1.
Why 1?
So option number 2.
हाँ, why 2?
Okay. So I don't know.
See. When the X is different, rather I should say when the alkyl group R group is same, then only compare, then iodine will be faster, followed by bromine, followed by chlorine, followed by क्लोरीन, है ना. अगर आपके पास क्या ग्रुप सेम है, आर ग्रुप आपके पास अगर सेम है, देन आपको कंपेयर करने की जरूरत नहीं है आर ग्रुप्स को, राइट. फॉर एग्जांपल यहाँ पे देखिए अल्काइल ग्रुप सेम है दोनों का, है ना. दैट मींस हियर यू डोंट हैव टू कंपेयर व्हाट, यू डोंट हैव टू कंपेयर द अल्काइल. आपको क्या कंपेयर करना है, क्लोरीन और आयोडीन में, तो क्लोरीन विल बी आयोडीन विल बी फास्टर, ठीक है. बट व्हेन द एक्स ग्रुप इज सेम, उसके बाद आपके पास you will have two options, then you will have to look at SN1 or SN2. When the R group is same, then you don't even have to look at SN1 or SN2. Then what you have to do, if it is SN1, then what will be the order? 3 degree is faster, then 2 degree, and then 1 degree. If it is SN2, then 1 degree will be faster, followed by 2 degree, followed by 3 degree. ठीक है, अब इसमें बताइए SN1 में कौन सा फास्ट होगा? 1 degree, 2 degree, 3 degree. You have to look at the alpha carbon.
Degree.
3 degree, right? 3 degree will be fastest, ना?
Yes.
So कौन सा फास्ट होगा? C फास्ट होगा या फिर ऑप्शन नंबर 1 फास्ट होगा? आप उल्टा बोल रहे थे। SN2 में कौन सा फास्ट होगा बताइए? यहाँ पे D में 1 और 2 which will be faster?
Option number 2.
उसमें भी आप उल्टा बोल रहे थे। अच्छा, now in SN1 you said it correctly, iodine will be faster. यहाँ पे जो ऑप्शन है आपके पास, यहाँ पे everything is same. Here the R group is different, and R group is how it is different. It is not different in 1 degree, 2 degree, 3 degree. It is different in the unsaturation, alpha unsaturation. So please remember, alpha unsaturation always slows the reaction. So where is alpha unsaturation? This is the alpha carbon in the first option. So it will be slower.
Yeah.
It will be slower. So 2 will be faster. Got it? Yes or no to me?
Yes.
Okay. Now write the next thing. The effect of solvation. रिफत आमना कुछ आ रहा है आपको? हाँ रिफत,
हाँ सर,
आ रहा है? थोड़ा मोड़ा आ रहा है। ठीक है, देखिए आप याद से देखिएगा, ठीक है लेक्चर। उसके बाद आपको अगर डाउट्स होंगे तो प्लीज हमको बता दीजिएगा, हम एक्स्ट्रा क्लास ले लेंगे आपको। ठीक है, ठीक है, आपकी जिम्मेदारी रहेगी, लेकिन उसको देखना, जो रिकॉर्डिंग्स है उसको देखना आपकी जिम्मेदारी, उसके बाद जो डाउट्स आए वो मेरी जिम्मेदारी। ओके, ठीक है। नाउ effect of solvation, है ना? effect of solvation, or we can write also effect of solvent. What type of solvent we are using in the reaction, that is also going to affect whether we are getting SN1 faster or SN2 faster, है ना? And what type of solvent do we use for SN1 and what type of solvent do we use for SN2? See, solvent there are of two types. Solvent की जो इसमें है, there are of two types solvent. One are called non-polar solvent. Non-polar solvent have the mu net, that means the dipole moment will be equal to what? 0. Examples for this will be CCl4. Then you will have some things like not other examples, CS3, C double bond O, CS3. This is acetone. And if you have liquid carbon dioxide, then also it will be what? Non-polar solvent. So these are what? These are examples of non-polar. There is also one which is known as DMS. It is something like this: CS3 carbon double bond S and CS. Here you have carbon. And here you have sulfur, and here you have CS3. Okay, this is dimethyl sulfoxide. Here we have sulfur and then oxygen. And this solvent is not used in your part 5 today. Non-polar solvent, and then we have polar solvents. Now, polar solvents, they will have mu net, which will not be equal to 0. That means they will be polar. They will have some kind of dipole moment. They will have some kind of dipole moment. Now, the polar solvent, it is further divided into two categories. The polar solvent, it is further divided into two categories. What are these two categories? One, we have polar protic. And the next one, we have polar aprotic. Polar protic solvent and polar aprotic solvent. Now, the polar protic solvent, the one that you have to remember is the one which have hydrogen bonding. That means this will have hydrogen which is directly connected to H, directly connected to fluorine, oxygen, or nitrogen. So these are what? These are polar protic solvent. Polar protic solvent. And in polar aprotic solvent, you will have two categories. So polar protic solvent, they will have two, not two categories, but I will say they will have two different attributes. That mu net will not be equal to 0. It will have some mu net, and they will also contain hydrogen bond. Polar aprotic solvent, they will have, wait a second, let me write it not like this. So they will have two characteristics. The first characteristic will be mu net is equal to something not equal to 0, and they will also have hydrogen bonding. Polar aprotic will have two characteristics. One of the characteristics will be mu net is not equal to 0. They are polar, and there will be no hydrogen bonding here. Okay, acidity. So what is hydrogen bonding? Hydrogen bonding means hydrogen directly connected to chlorine, oxygen, or nitrogen. Okay, write this down. Done, everyone? Is on, please tell me.
Yes.
Yes. Okay. Now listen. Again, what happens in SN1? SN1 may we form formation of carbocation. So if we have C positive, there is carbocation here, carbocation. And let us say we have something like water. So water will be what? H2O. H2O will be surrounding the carbocation like this. And we all know that oxygen will have delta negative charge, right? And the hydrogen will have delta positive. Now this delta negative of what? Delta negative of oxygen, delta negatives of oxygen, and the positive sign of carbon, they will interact with each other. They will interact with each other, and it will be stabilizing effect. Positive and negative, it will be stabilizing. That is why this is what it is an example of polar protic solvent. Why it is polar protic? Because you can easily see that there is a dipole. Delta negative is there in oxygen, and delta positive will be there in hydrogen. So there is a polarity here. And why it is protic? Because hydrogen is directly connected to oxygen. So hydrogen, when it is directly connected to fluorine, oxygen, or nitrogen, then it is an example of what? Polar protic solvent. Other examples of polar protic solvent will be CH3OH, right? Methanol, CH3, CH2OH. So all of these are examples of what? Polar protic. You can see that hydrogen is connected to what? Electronegative atom. Hydrogen is connected to electronegative atom. Okay. Another example will be acetonitrile, in which you will have CH3CN. Okay, so these are examples of polar protic. But the only thing that you have to remember is formation of carbocation. It will be what? Still will be stabilized by polar protic solvent. And how it is stabilizing? Since polar protic solvent will have a delta negative charge and a high delta negative charge, it will interact with the carbocation, and this will be an attractive force. And whenever we have some kind of attractive force, what is there? We will get stabilization. We will get stabilization. So do you understand why SN1? In SN1, formation of carbocation is what? It is stabilized by polar protic solvent. And that is why in SN1, we use polar protic solvent. Rifat, Zad, tell me, you understand it? Yes or no? Tell me.
Yes.
Yes.
Okay. Okay. So this is in SN1. This is in SN1. Okay. So for this you will write. Okay. Now since you have understood, please write with me. In SN1, the intermediate is carbocation, and it has more charge than the substrate. It has more charge than the substrate, due to which what will happen? Due to which polar solvent increases the stability of carbocation. Increases the stability of carbocation. Done? Yes or no? Tell me.
Yes.
Okay. You'll write therefore rate of SN1 increases in the presence of polar protic solvent. So polar protic solvent, they stabilize wherever you have more charge. Okay. So here we had carbocation, there it had more charge and it is stabilizing the carbocation. Now in SN2, what will happen? In SN2, what do you need? You need a stronger base, right? You need a stronger base. And what do you need? And you need a stronger, strong nucleophile. And this nucleophile may always contain some negative charge. In SN2, it may contain what? Negative charge. Now what will happen? This reactant, which is your nucleophile, it will have higher charge than the transition state. Transition state, it does not have any charge in SN2. है ना? So इसमें क्या होगा? It will stabilize the reactant rather than the transition state. So you'll write in SN2. Sorry. In SN2, the nucleophile न्यूक्लियोफाइल क्या है आपका? रिएक्टेंट में आता है. The nucleophile has more charge than the transition state, and due to which polar protic solvent can interact with nucleophile and increase the stability of reactant. And we don't want to increase the stability of reactant, because if reactant is stable, then the rate will decrease. So you will write, therefore, the rate of SN2 decreases in the presence of what? In the presence of polar protic solvent. Polar protic solvent. Write the next point. You will write, since the reagent is always going to be polar, we need to use only polar solvents in nucleophilic substitution. Okay, in SN, what do we need? We need only polar solvent. Now, out of the polar, we have two options, polar protic or polar aprotic. And then you will write the conclusion. What is the conclusion here? The conclusion is polar protic solvent increases rate of SN1. Polar aprotic solvent increases rate of SN2. This is the conclusion. The only thing you have to remember is that polar protic solvent, it stabilizes the charged species. In SN1, the charged species is carbocation. In SN2, the charged species is the nucleophile. If it is stabilizing the carbocation, that means there will be faster reaction. Carbocation jaldi jaldi ban jayega, so the reaction will be faster. But if in SN2 it is stabilizing the nucleophile, that is a reactant, then the reactant will not even react. That is why we use polar aprotic solvent rather than polar protic in SN2. ठीक है?
Yes.
Everyone done? Yes or no? Please tell me, all of you.
Yes, sir.
Okay. What about Rifat, done?
Done, sir.
Okay. So, now let us write what? Let us write the reactants. We have just now looked at what? We have just now looked at the mechanism of nucleophilic substitution. Now you will write SN of haloalkane. We wrote about general nucleophilic substitution. You will write SN of haloalkane, nucleophilic substitution of haloalkane. Okay, SN of haloalkane. Now, whatever I'm writing, this is going to be important. So please write number 1. Wait a second. Reaction of haloalkane with KCN and AgCN. Okay, reaction of haloalkane with KCN and AgCN. So you'll look at two cases in which one of the reactions is KCN and the other reaction is with AgCN. One reaction is KCN and the other is with AgCN. So please write case 1. Case 1, reaction with KCN is there in your NCERT, but it can be also what? NaCN. It can be also what? CSCN. Okay, so all of these examples are. Please write what happens when we react haloalkane with KCN or AgCN. Sorry, KCN or NaCN or CCN. Please write with me when haloalkane is treated with I am taking KCN because KCN is there in your NCERT. Okay, reacts when haloalkane is treated with KCN, it leads to formation of alkyl cyanide. It is also known as alkyl nitride. Alkyl nitride. Now let us write the mechanism why it happens like this. See, first of all, we will have KCN. We all know what KCN is. What it is, a strong electrolyte, and because it is a potassium is in group 1. It is a pure metal, so it will break into K plus and Cn negative like this. It will break into K plus and Cn negative. Then we have haloalkane, that is Rx, and now Rx, there will be delta positive here and there will be delta negative here. Okay, plus we have here KCN, in which we have K plus and we have Cn negative. Okay, चलिए Hanifa, okay, Hanifa just joined. Rifat, अच्छा Hanifa ने अभी आई है. अस्सलाम वालेकुम Hanifa, am I audible? चलिए ठीक है, audible नहीं है. Rifat, can you hear me?
Yes.
ठीक है, यहाँ पे बताइए दिस Cn नेगेटिव जो है आपके पास नेगेटिव चार्ज, ये R पे अटैक करेगा या फिर X पे अटैक करेगा? This negative charge R, very good, है ना? So what will happen? This Cn negative it will attack on the R group like this, okay, and this X negative it will leave as a leaving group. X negative निकलेगा तो फिर K plus उस पे अटैक कर देगा. Okay, so K plus will attack after X minus leaves, so we'll get RCN. The important thing is that there is a bonding with carbon rather than nitrogen, and you will form. Let me explain it like this: R plus you will have Kx, whatever the haloalkane was, Kx. Okay, why it is happening like this? Once, if you look at Cn, Cn negative structure is like this: carbon, the triple bond, nitrogen with a lone pair, carbon with a lone pair and negative charge. Okay, so this negative charge is due to this lone pair which is there in carbon. Carbon generally it will only have 4 electrons, but it has 5 electrons in the valence shell. That is why it is having a negative charge here. So what happens now? There is a chance that this carbon can attack from the lone pair or nitrogen can attack from the lone pair. But we all know that carbon-carbon bond will be more stronger. That is why it has a property of catenation, right? Carbon, it bonds with other carbon atoms and it forms long chain because it makes strong bonds with carbon. So carbon will make strong bond with carbon. That's why it prefers the attack from carbon rather than nitrogen. So attack happens from what? The lone pair that is present in the carbon atom. ज़्यादा आपको समझ में आया है? So tell me. Okay, so now you will write. Please write. Since KCN has more ionic character. Hanifa, am I audible? आवाज आ रही है आपको? Since KCN has more ionic character.
Yes, sir.
Where were you in the last 2 classes, Hanifa?
I was there in the last class where we had a test.
And so you were there in the last class.
No,
Achha,
I,
achha. But I think, did you give the test?
no, sir, I didn't.
आप लाइक अब शायद लेट आई थी ना बहुत.
Yes.
I mean you came just before the test I think. Am I right?
Yes, sir.
फिर आपने रिकॉर्डिंग देखा.
Yes, sir.
Okay. Any doubts from there?
No, sir.
No, पक्का.
No.
कहाँ
We
तक क्या
did.
था हमने बताया. हाँ बताइए.
We did till the SML and mechanism and all.
Mechanism and notebook देखिए बताइए. What is the last topic that you have written?
The last thing we did was we were doing the we started with the 11th grade basics for understanding organic chemistry.
नहीं उसके बाद रिकॉर्डिंग्स देखी होंगी ना आपने, तो उसमें नोट्स नहीं बनाया आपने.
I did, but I don't have the notebook right now.
एक नोटबुक. अब लाइक ये क्या बात है, इतना क्लास हो गया तो नोटबुक लेके आइए सर ना. Where is the
No,
notebook?
sir.
You don't have it?
Actually,
हाँ
I am in India now, so that's why.
तो आपने नोटबुक ही नहीं लेके आए.
I couldn't get all of my books.
अच्छा. सो कौन किस किस सब्जेक्ट का किताब लेके आई हैं आप बताइए.
I have one book for all of them.
अच्छा एक ही किताब आप लेके आए हैं. अच्छा तो रिवाइज वगैरह कैसे की. चलिए ठीक है. Okay, since KCN has more ionic character, therefore it gives CN ion, CN negative ion completely, which acts as ambidentate nucleophile. Okay, ambidentate means it can attack from both carbon or nitrogen. So it has two attacking sites, two different atoms which can attack. Please remember, what are ambidentate or ambident nucleophiles? The nucleophiles which can attack from two different atoms, है ना, एक carbon है दूसरा nitrogen है. In which, please write, in which carbon and nitrogen. और आज आप लेट क्यों हो गई?
I had iftar. That's why
अच्छा.
I was fasting today.
Okay. In which carbon and nitrogen both have tendency to donate electron pair to what? To the alkyl group. No, that is the meaning of ambidentate nucleophile, two different atoms which can donate the electron pair. But carbon bond, what bond? Carbon bond is more stronger than carbon nitrogen bond. Therefore what will happen? Therefore the alkyl group is attacked by carbon of CN negative and gives alkyl cyanide also called this alkyl nitrile S product. Write this down, let me know when you're done.
So then,
Done. So for example, you have CS3 CH2 Br. We are reacting this with KCN. Okay. So covalent bond हमने दिखा दिया, लेकिन जनरली covalent bond इसमें तो होगा नहीं. We will write it like this, KCN. What will be the product? You just need to remove this Br and K. It will form KBr, and then what? CH2 will attach. CH2 will be attached on Cn. ऐसे लिख दीजिएगा, CH3 CH2 Cn. Okay. So if you have something like this, let us say you have a cyclo compound. There is an iodine group here. Plus you have KCN. Then this iodine and this potassium will make a bond of Ki, and what you will get? You will get Cn attached in the place of iodine. So Cn will replace iodine. Write the product for these two. And send the answers on WhatsApp. ठीक है, जल्दी भेजिएगा, बहुत ज्यादा टाइम लगाते हैं आप लोग, फिर सवाल देते थे. You just need to replace the Br as it is. कुछ नहीं करना change. Whatever the alkyl group is, remember what is
actually
alkyl?
साइड बनेगा ना सेकंड थर्ड वाले में.
हाँ, वो भेजिए ना आंसर आप.
Okay.
Send your answers. इतना डर क्यों लगता है आप लोगों को काटने में? गलत होगा तो काट दीजिएगा. And please, those who write with pencils and all ना, please don't write your answers with pencil. अगर यहाँ पे आपने कुछ गलत प्रोडक्ट बनाया तो उसको काटिए. Okay. Why? Because once you're revising this ना, अगर यहाँ पे कटा हुआ आपको नजर आएगा, then you will focus here more. ये एक सवाल एक बार गलत हो चुका है मेरा. Okay, so please never use pencils. Whatever you write should be fair, direct. The notes can be as dirty, मतलब जितना भी आप गंदा बना सकते हैं, इसमें कोई दिक्कत नहीं. But after that you have to make a short note always. So जो short notes हैं वो साफ होने चाहिए. So in the short notes you will not write all the explanations like this, right? अब जैसे short note पे आपके पास ना ये explanation नहीं आएगा, since KCN has more ionic character, इतना लंबा तो नहीं दिखेगा short note में. So you make the short notes very properly, very neatly and cleanly, but whatever you're writing right now, it should be fair, है ना? उसमें आपके पास कटिंग पुटिंग सब कुछ होना चाहिए. ऐसा नहीं कि एक बार पेंसिल से बना रहे फिर उसको इरेज करके ठीक कर रहे हैं. Don't do that. Okay. No one has sent me answers.
Sir, your number is there in the group, right?
Yeah, it ends with 007. This is my number. Very good, correct. Yes, Rifat. The answers are right. Waiting for Zaid and Hanifa. Whenever I ask you to send photos ना, उसमें don't click the photo first. आप पहले WhatsApp के कॉन्टैक्ट में चले जाइए, देन वहीं पे जो आइकन रहता है फोटो का उसी से क्लिक करके भेजा दीजिए. हाँ करेक्ट.
Sir, mine is loading, so it might get it.
क्या हुआ हनीफा? इंटरनेट स्लो है?
Yes, sir.
अच्छा, तो आपने अपलोड कर दिया, टाइम ले रहा है?
Yes, sir.
अच्छा ठीक है. So here you will get CH3 carbon, CH3 CH3 and see always you will make the reactant first. ठीक है, जो reactant का जो alkyl group है उसको पहले, then you will make the bond which is formed. CN bond is formed. CH2 double bond CH CH2 and then there will be CN. चलिए, yeah Hanif, I got yours. Very good, correct. Right, next case 2, reaction with AgCN. The first reaction we saw was with it was with KCN, and what will happen with AgCN, right? To case 2. Case 2. Reaction with AgCN. Reaction with AgCN. Now AgCN is what? Ag is a metal of D block. Ag is a metal of D block. And it is also on the right hand side of the D block. That means it has some covalent character. It has more covalent character than ionic character. And due to which what will happen? Please write. AgCN has more covalent character, due to which it does not separate into ions. That will what happen? It will not separate into ions. No, it will not give you ions. Hence, in AgCN, only nitrogen has tendency to donate electron. Has tendency to what? Donate electron. To what? Donate electron to the alkyl group. क्यों कार्बन क्यों नहीं कर सकता? Because carbon has a bond with Ag to the alkyl group. And forms alkyl isocyanide, also known as, or alkyl isonitride. Okay, alkyl isonitride. That means in Rx plus Ag. Now Ag, it has a bond with carbon. Then carbon, and then there is a triple bond with nitrogen. Nitrogen with triple bond, it will always have one lone pair. Now this lone pair will attack on R group. This X will leave, and you will be getting R N triple bond C. यहाँ पे lone pair रहेगा as it is, plus AgX. Oops, wait a second. This lone pair is already done, so it will not be here. Plus AgX. This will be the product. Okay. So for example, you have CH3, CH2, Br plus AgCN. It will be giving you CH3. CH2, NC. Similarly, if you have something like this, iodine. अच्छा यहाँ पे लिख लीजिए plus AgBr. Now, in this case, what you have to do, you have to replace the halogen with Nc. Okay, rather than Cn, you have to replace it with Nc. Done, yes or no? Please tell me.
Yes.
Right conclusion.
Sir, can you show the example?
Yeah. देखिए कंक्लूजन हम लिखाते रहे इसी वजह से ताकि आपको शॉर्ट नोट्स लिखने में आसानी हो ना. सो इन शॉर्ट नोट्स यू विल जस्ट राइट द कंक्लूडिंग पार्ट्स, बट आई विल नॉट राइट कंक्लूजन फॉर ईच एंड एवरीथिंग. हम एक दो का कुछ कुछ का लिखा देंगे जहां हमको ध्यान रहेगा. एंड आफ्टर दैट वंस यू आर प्रिपेयरिंग द शॉर्ट नोट्स, फिर आप खुद दिमाग लगा के अपना कंक्लूजन लिखिएगा वहां पे. ओके, so this whole thing that we have learned till now, what we can conclude from here, we can conclude that reaction of haloalkane with KCN gives alkyl cyanide or alkyl nitride. Both are these same thing. Alkyl nitride लिखते कैसे हैं? RCN. Okay, and haloalkane is what? RX. Okay, and what you can write the same thing. Reaction of haloalkane with AgCN gives alkyl isocyanide. Rather than cyanide, what it will give you? Isocyanide. And alkyl isonitride. ठीक है, सी यहाँ पे हम एक और चीज दिखा दे रहे हैं. Some people they really like sentences, so they can write these two sentences. है ना, जिनको sentences पसंद है. Some people they really like what they write. They are more what I can say, they are more comfortable with equations and all. So you can write it like this also. Rx if you react this with KCN, it will give you RCN plus KX. If you react this with AgCN, give you RNC plus AgX. Okay, so you can write it like this also. Both are same things.
So done.
Done. Okay. Now we have another which is a reaction with another which is important. That is reaction with what? See, one we did similar type of thing is going to happen with reaction of haloalkane with KCN AgCN, that is we have done. Then we will do KNO2 and AgNO2. Okay, so reaction of haloalkane, please write. This is also important. Okay, reaction of haloalkane with KNO2 and AgNO2. So in this also you'll write case 1. Case 1 is what? Reaction with KNO2. Now, in reaction with KNO2, what is going to happen? I hope you all know. In this, what will happen? This nitrogen will not react. What will react? Oxygen will react. So please write when haloalkane reacts with KNO2, and then it forms alkyl nitrite. That means, first of all, KNO2 will break apart into K positive, plus you will get NO2 negative. Okay, so NO2 negative, in this the negative charge will be on oxygen atom, like this. The structure is oxygen, single bond nitrogen with a double bond oxygen. So this oxygen has 2 lone pairs. This oxygen has 3 lone pairs, and due to the 3 lone pairs, it will have a negative charge. Okay, have a negative charge. Now, as you can see, oxygen is what it is, negatively charged, so it will be very readily available for the donation of electron, and that is why what is going to happen if you react with CH3, CH2, Br, and you react this with KNO2, it is going to form CH3, CH2, ONO, like this. Okay, that means reaction is happening through what? Oxygen atom, through oxygen atom. So please write, since KNO2 is ionic, it will dissociate into K positive and NO2 negative. K positive and NO2 negative. In NO2 negative, the negative charge is on which atom? On oxygen atom. Hence, it attacks the alkyl group, leading to formation of alkyl nitrite. Okay, so you will show it like this: Rx plus K plus and ONO, and this negative charge it will attack on the R group. This X will leave. RONO plus KX. Okay, this is alkyl nitrite. जल्दी लिखिए. Let me know when you're done. Done, yes or no, please tell me.
Yes.
Right, case 2. Reaction with AgNO2. So when haloalkane, they will react with AgNO2, then what is going to happen? AgNO2 is what it is? Covalent in nature, right? It is what it is? Covalent in nature. That is why the oxygen and Ag, they will be bonded like this. So you will write when haloalkane reacts with AgNO2, and then it forms nitroalkane. Rx plus AgNO2 will give you R, and the bond will be with nitrogen. Okay, NO2 plus AgX. So here the reaction is happening towards, here the reaction is happening with what? It is happening with nitrogen. Why it is happening with nitrogen? It is happening because, right, since AgNO2 is covalent in nature, it does not dissociate into ions. It does not dissociate into ions. Now, if it will not dissociate into ions, then what is going to happen? Then oxygen and nitrogen both will have the tendency to give the electron. Why? It does not dissociate into ions, and it has AgON double bond O. So this nitrogen will have lone pair, and this oxygen, it is also having lone pair electrons, right? So now both of these can give electrons. Does not dissociate into ions. Hence, both nitrogen and oxygen has tendency to give electrons. Okay, has tendency to what? It has tendency to give electrons. अच्छा, अब बताइए oxygen और nitrogen में which will give electron, which has more tendency to give electron? What do you think? Tell me. Nitrogen atom or oxygen atom? Which has more tendency to give electron? कैसे देखेंगे? क्या हम लोग देखेंगे नाइट्रोजन और ऑक्सीजन के बारे में? Tell me as an atom. Zaid, Rifat, Hanifa.
So nitrogen maybe.
Why nitrogen will give more electron?
So when it will give electrons,
Why nitrogen? When it will give वो नहीं. Why? ये तो हमको पता है नाइट्रोजन दे रहा है यहाँ पे because nitrogen is making the bond. But why nitrogen and not oxygen? What is the difference between nitrogen and oxygen? क्या क्या different होता है nitrogen oxygen में बताइए? Think. Hanifa, you tell me. If I talk about atoms, then क्या क्या compare कर सकते हैं atoms के बारे में? Remember the third chapter of 11th standard. What was the third chapter of 11th standard? Periodic properties, right? So periodic properties में याद कीजिए what are the different things that we compared between atoms? Yeah, Hanifa, tell me. What things can be different?
The amount of lone pairs.
Number of lone pairs. ये compare करते थे हम लोग देखिए. If you remember your class 11th standard, in periodic properties, why periodic properties is a very important chapter? Because wahi properties, they determine the chemical reactivity. They determine the chemical reactivity. The properties that we used to remember and we used to do was, we used to do atomic size, right? Then atomic size से पहले एक Z effective नाम का चीज था, effective nuclear charge that we used to do, that used to determine each and everything. Atomic size था. What else after that? Atomic size. Then atomic size, ionic size एक ही चीज है. Then we did electron gain enthalpy. Yes or no? Then we did ionization enthalpy. Yes or no? These are the things that we used to do: electron gain enthalpy, atomic size, ionization enthalpy. What else? What else we used to do? Tell me. एक चीज करते थे जो कि बहुत इंपॉर्टेंट है. I have not named it yet. Periodic properties में. नहीं याद. लास्ट वन. 4 हो गए. एक और था. What is one more property of याद ही नहीं. Electronegativity. Yes or no? And electronegativity is very important in organic chemistry. जब भी आपके पास atoms के बारे में बात आएगी, whenever you are comparing two different atoms, you will always remember electronegativity. तो यहाँ पे electronegativity, we know that oxygen has more electronegativity. That means it does not want to give its electron, right? It wants to what? It wants to attract and keep the electron in, or even in the bonded state, it wants to keep the electron. And that is why what will happen? Nitrogen has more tendency to give the electrons rather than oxygen, because oxygen has higher electronegativity. Hence, both nitrogen and oxygen has tendency to give electron, but due to lower electronegativity of nitrogen, it will easily attack alkyl group and form nitroalkane. ठीक है, form alkane. यहां तक लिख लिया ना आप लोगों ने? Yes or no?
Yes.
ठीक है. Tendency to give electrons, but due to lower electronegativity of nitrogen, it will easily attack the alkyl group and form nitroalkane. Now you'll write questions. ठीक है. So number 1 में लिखिए आप. You have iodine. Reactant, you have KNO2. Here you have AgNO2. Please write this, okay? करके भेजिए आंसर, है ना? Okay, Hanifa and Saad, you have sent me answers. अरे ये क्या है हनीफा? बॉन्ड नहीं बनाना है क्या? You look at the third question, what you have written.
The plus sign.
KNO2 से क्या बनता है? जाइए दोबारा देखिए. Look at the topic and write the answers once again. ज़ैद आपने भी गलत किया हुआ है. एक बार देख तो लीजिए कैसे होता है, फिर कीजिएगा.
Okay.
KNO2 में क्या होता है देखिए, आया लिखा नहीं है क्या हमने? तो अजीब ही बात है आप लोगों की. तो यहाँ पे हमने आपको दिखाया हुआ भी है कि क्या बनेगा, कैसे बनेगा. द बॉन्ड विल बी विद द कार्बन. ऑक्सीजन का बॉन्ड होगा या कार्बन नाइट्रोजन का बॉन्ड होगा?
Sir, oxygen.
तो फिर क्या लिखा है आपने? Rifat, I have not received your answer. अनीफा सारा गलत है आपका. नहीं, सेकंड वाला गलत ही समझिए. आपने ध्यान लगा के नहीं किया है उसको, तो गलत ही समझिए फिर.
Sir, can you show the AgNO2 वाला reaction आपने जो लिखा था?
आपने लिखा नहीं है?
नहीं, मैं I think मैंने गलत लिखा.
उसमें भी गलत लिख दिया आपने. ये है रिएक्शन, देखिए. ये Rifat, yes, Rifat, no, you are correct, very good. Your answers are right. लिखा आपने हनीफा?
नहीं सर.
लिखिए, जल्दी लिखिए. Done? Yes or no? Please tell me.
Yes.
तो भेजिए ज़ैद, भेज दिया आपने?
Yes.
ठीक है, सिर्फ ONO लिख दीजिए. ठीक है, ज्यादा बॉन्ड बनाइएगा, सब कुछ दिखाइएगा तो उसमें कुछ गलती होने के चांसेस है. ओके,
Okay.
so just write ONO. Whenever you have potassium, you will be bonding with oxygen. यहाँ पे किसके साथ बॉन्ड होगा? यहाँ पे बॉन्ड होगा N के साथ, कार्बन एंड नाइट्रोजन, नाइट्रो एल्केन you will get. Here you will get what? हनीफा बताइए, थर्ड केस में कार्बन और ऑक्सीजन का बॉन्ड होगा या नाइट्रोजन का बॉन्ड होगा?
Oxygen.
वेरी गुड, ऑक्सीजन। बस ऐसे ही ध्यान दे दे के लिख देना, you will get NO2। ठीक है, तो कंक्लूड, यहाँ के कंक्लूजन में आप कैसे लिखिएगा? इफ यू आर राइटिंग द रिएक्शन यू राइट RX when it reacts with KNO2 it is going to give me RONO, when it is going to react with AgNO2 it is going to give me RNO2। ठीक है, इसको में लिख दीजिएगा, इसको कहते हैं अल्काइल नाइट्राइट और इसको कहते हैं नाइट्रो एल्केन। Done everyone? Yes or no? Please tell me.
Yes.
Is everyone done? ठीक है। Now there are some other reactions of haloalkene with what? With different types of nucleophile and they give different products। तो उसको एक साथ ही लिख देते हैं। ये important cases थे, दो जो केस थे आपके। One was what? KCN AgCN and the other was KNO2 AgNO2। There are other reactions that you are going to write। Okay, so please write, ऐसे लिखिएगा, इनको हम बता रहे हैं। You will write RX। Okay, then इस तरह से इसको स्पाइडर वेब डायग्राम कुछ बोलते हैं। ठीक है, सो फर्स्ट यू विल सी ऑल ऑफ दिस aqueous KOH और NaOH। ठीक है, सारे रिएजेंट्स लिखिए, उसके बाद हम आपको प्रोडक्ट्स बताएंगे। प्रोडक्ट्स हम कुछ का ही लिखेंगे, बाकी सारा प्रोडक्ट्स आप खुद से लिख लीजिएगा। ठीक है, हम बताएंगे कैसे लिखिएगा आप लोग। react with H2O, can react with R, C triple bond C negative, Na positive, AgNO2 का तो आपको पता है क्या होगा, है ना? फर्दर और आप क्या लिख सकते हो? और यहाँ पे you can write KNO2, KCN, AgCN, you can also write NH3। और क्या लिख सकते हैं इसमें आप? Write the reagents। There is also one RCOOAg। ये सारे रिएजेंट्स लिख लीजिए आप लोग। लिख लिया आप लोगों ने? yes or no, tell me।
Yes.
हनीफा, ओके। व्हाट अबाउट रिफत एंड हनीफा, लिख लिया आप लोगों ने? ओके, देखिए, अच्छा हनीफा डिस्कनेक्ट हो गई, जस्ट वेट अ सेकंड। ओके, हनीफा इज रीजॉइनिंग। हनीफा, यू आर बैक, एम आई ऑडिबल? yes Hanifa?
Yes, sir.
Okay, so you tell me Hanifa, R and X is a halogen, chlorine, fluorine, bromine or iodine, so which will be more electronegative, carbon or the halogens, which is more electronegative? Hanifa, पता है आपको? नहीं पता, ये बताइए पहले।
I think
Sorry?
the halogen.
Halogen, ठीक है, हाँ halogen, correct। So it will have delta negative and it will have delta positive, correct? Yes or no, tell me, right?
Yes, sir.
Yes or no? Okay, that means, and also if it is going to break you will get R positive and X negative, तो यहाँ पे whatever reagent we have, the reagent will also have a positive part and a negative part. Yes or no, Hanifa?
Yes, sir.
Right, it will be also having positive and negative. So what do you think, which part will attack on R, the positive part or the negative part? R पे कौन अटैक करेगा? Tell me. Positive or negative? Which one? Which part will attack? Negative part, right? Because what? Negative will be attracted towards positive and it will attract. ठीक है, अब यहाँ पे बताइए. We have KOH and NaOH. Okay. So KOH जो होगा dissociate कैसे dissociate होगा? It will break into
K plus OH minus.
Very good. तो यहाँ पे
K
बताइए.
plus and OH minus.
हाँ, very good. K plus and OH negative. So what will attack on R here? OH negative will attack. Correct? Yes or no?
Yes.
So you'll get ROH, that is alcohol. Okay, you will get ROH, alcohol. Plus what you will get? You will get KX or NaX. You will get KX or NaX. आसान है, yes or no? All of you tell me. Rifat, Zad.
Yes.
Yes. अच्छा, H2O में क्या होगा? I hope you have seen the auto ionization of H2O. H2O breaks apart into H plus and OH negative. Yes or no? Tell me.
Yes.
यहाँ पे भी कौन अटैक करेगा बताइए? What will attack from H2O?
Sir, OH negative.
Very good. OH negative will attack, है ना? चलिए. So you will write what again? Alcohol लिख लीजिएगा यहाँ पे ROH. रिफत आ रहा है आपको? Yes or no? Tell me, रिफत. Plus you will get HX. अच्छा, यहाँ पे बताइए, देखिए कौन सा पार्ट अटैक करेगा? C नेगेटिव वाला है ना? तो this whole part will attack and this Na positive will not attack. So you will have something like R, C, and then rest you will write it like this only. C triple bond C connected with, let me write it R dash here. ठीक है, तो ये कोई दूसरा alkyl group हो जाएगा. Fine. So it just means that R and R dash can be same or can be different also. Now we have AgNO2. AgNO2 का यहाँ तक तो आप खुद से लिखिए. इन सब में क्या होगा? Now in NH3 what will happen? NH3 में this one lone pair will attack and you will get R and hydrogen जो है वहां से निकल जाएगा NH2 plus you will get HX. Here you have RCOO Ag. Now Ag is a metal, so it will have a positive charge. It will dissociate and it will lose the electron. So you will get what? You will get, यहाँ पे भी R dash लिख देते हैं. You will get R, which will be bonded with oxygen. It will be further bonded with carbon, double bond, and R dash like this. Okay. तो इसको आप ऐसे भी लिख सकते हैं. Rather than writing it like this, you can just write R COO R dash. ठीक है? No, wait a second. This R will not be having dash. This R will be having dash. R dash. You be R dash the COR and then the alkyl group. Now, lithium aluminium hydride. What is this known as? Lithium aluminium hydride. So as you see, hydride. Now, lithium aluminium hydride. Hydride means what? Hydride means H negative. Chloride means Cl negative. Iodide means I negative. Hydride means H negative. Now, if H is negative, it will attack on R group and you will get alkene. RH, this is alkene. ठीक है, तो ये चारों तो आप खुद से लिख लीजिएगा. चलिए, प्लीज राइट दिस डाउन. लेट मी नो व्हेन यू आर डन.
Sir, done.
Okay. What about others? Hanifa and Rifat? Done?
Done, sir.
Okay, fine. Okay, so I think there is one question which is very important in your NCERT. Do you have NCERT textbook?
Yes.
Okay. So there is one question. Okay, I'll write that question later on. लेकिन अभी आप लोग एक काम कीजिए. You write what is the definition of ambident nucleophile or ambidentate nucleophile. They can directly ask you ambident nucleophile also. Define ambident nucleophile. Okay, please write. The nucleophile in which more than one donor site, more than one donor sites are present, more than one donor sites are present for chemical reaction. That means it should also take part in reaction. For chemical reaction, it's called ambident nucleophile. Examples are, what are the examples? You have CN negative, you have AgNO2. Right, in AgNO2, both oxygen and nitrogen can donate the electrons. These are some examples of ambidentate nucleophile. Done, yes or no, tell me?
Yes.
The question that I was talking about was, please write. Neopentyl halide is a primary haloalkane, but still it does not show SN2. Why? So the answer lies in the structure. If you will look at the neopentyl halide, I have wrote in the IUPAC nomenclature what is neopentyl chloride. So what is neopentyl? So you'll have 5 carbons which are arranged in this manner: CH3, CH3, CH3. These are 4 carbons, and then you have CH2. Let us say we have Br. Okay, CH2Br. This is neopentyl halide. Neopentyl halide, or you can write this is neopentyl bromide. So right, because due to the high steric hindrance at alpha carbon. Okay, what is alpha carbon? This is your alpha carbon, the carbon which is directly connected to the halogen. This is alpha carbon, and this alpha carbon, which has a very big group, right? It has a very big group of how many carbons? 4 carbons. That is why what is going to happen due to steric hindrance at alpha carbon, the nucleophile is not able to attack from backward direction. Hence, it does not show SN2. Done?
Yes.
Okay. अच्छा, and I hope, see, if you remember in the last class जो हम लोगों ने पढ़ा था उसमें, this is very important. Comment on the reactivity of SN1 and SN2 for the following. यहाँ पे you can see that these are what, this is vinylic halide, this is what, arylic halide. So vinylic and arylic, they will not show SN2 or SN1, or in any of the nucleophilic substitution they are not going to show, because there is a formation of double bond due to resonance here, है ना. इसमें क्या है main point, alpha unsaturation. If you have a double bond in the alpha carbon, if you have a double bond in alpha carbon, it will decrease the reactivity of both SN1 and SN2. It will decrease the reactivity of both SN1 and SN2. Now, another thing which is related to this, please write. Write in terms of questions only. Allylic halide is allylic halide is more reactive towards SN1. Towards what? Towards SN1, even when it is primary. Even when it is primary. That means if you have something like this, CH3, sorry, CH2 double bond, CH single bond, CH2 Br. Then what is happening? This Br will leave. In SN1, what is happening? You will form carbocation, CH2. The carbocation will only be formed when the bromine leaves. So you will have CH2 double bond, CH single bond, CH2, and this will have a positive charge. And this is now what? It is resonance stabilized, right? This is resonance stabilized. And since this is resonance stabilized, what will happen? It will be formed in a very higher amount and it will be formed very easily. This carbocation will be formed very easily. And if it is formed very easily, then the reaction will be, then allylic halide will be what? More reactive towards SN1. So what is the reason? Due to resonance, the carbocation of allylic halide is more stable. Allylic halide is what? It is more stable, and hence more reactive towards SN1. Okay, so if you get some type of question like this, where you have to compare the reactivity of, let us say, you have 3 carbons like this, Hannah? And you have here bromine. Here also you have 3 carbons and there is a bromine here. In this case, if you are comparing SN1, so you will say that यहाँ पे 2 degree, यहाँ पे 1 degree, right? But here you have to also see that it is what? It is allylic. That is why the SN1 of second carbon will be more faster due to the stabilization from resonance. Due to the stabilization from resonance. Okay, please write this down. Let me know when you're done. So SN1 and SN2 is complete. एक इसमें जो portion है, that is of stereochemistry, उसको हम आखिरी में बिल्कुल पढ़ाएंगे at the end. When you are very comfortable with the reactions and all, when we have done elimination reactions also, when we have done the reaction with metal and the reactions of haloarine. ठीक है? So reaction elimination reaction कल ये पूरा खत्म हो जाएगा elimination. then after that we will be doing reaction with metal and the halorine. उसके बाद जो class होगी then we will do stereochemistry, chapter end हो जाएगा. Okay, so I think we will be needing a few more classes. I think 2 या 3 क्लास तो आज चाहिए होगा. Okay, चलिए write this down. Let me know if you have any doubt. अच्छा, हनीफा and रिफत, please watch the lecture whatever it is remaining. ज़ायद आपने फोटो भेजा हुआ है? अच्छा अच्छा. ज़ायद AgCN का एकदम गलत है. ज़ायद look at AgCN, क्या फर्क है दोनों में? फिर AgCN और KCN में कोई फर्क ही नहीं रखा है आपने. देखिए क्या गलत है दोनों में से.
Yes, yes.
ध्यान से कीजिए, ध्यान से. छोटी छोटी गलतियां इन सब मार्क्स ले जाएंगी. ओके, रिफत एंड हनीफा, वॉच द लेक्चर्स. जो भी आपने मिस किया है, इफ यू हैव डाउट, आपका नंबर आपके पास मेरा नंबर है ही, बस हमें कह दीजिएगा सर हमने कर लिया ये डाउट्स, या फिर आई हैव सम डाउट्स, तो फिर हम एक एक्स्ट्रा क्लास अरेंज कर लेंगे. ओके हनीफा एंड रिफत, यस और नो, टेल मी.
Yes, sir.
यस, ठीक है. बताइए कब तक देख लीजिएगा लेक्चर्स को? व्हेन विल यू कंप्लीट? कल? स्कूल तो नहीं है ना अब आप लोग का?
No, sir.
स्कूल तो नहीं है, तो कल देख लीजिएगा, है कि नहीं?
Yes.
यस हनीफा, व्हाट अबाउट यू? आपकी आवाज ही नहीं आ रही. इंटरनेट लगता है आपके यहाँ ज्यादा खराब है. डाउनलोड करके रख लीजिए आप YouTube.
Yes, sir. I'll try.
हाँ, ट्राई नहीं करके ही रख लीजिए उसको. ओके, चलो बाय गाइस, थैंक यू, टेक केयर.
Thank you, sir. Bye.